are probably the two most confused terms in IT. And there's good reason, because there's a lot of redundancy. However, I'm going to go through these and hopefully clear up what the difference is. Again, let's not get confused yet. I'm going to cover these here very shortly. Now, we'll talk about the skills. The reality is, if we're going to work with data, we have to be good at certain things. And for you to be a data analyst or a data scientist, the skill sets are actually a little different. And I'm going to cover why they are a little different. So if you're someone that really likes to go out there and program, then maybe you want to get into areas such as machine learning or AI, or even data science. If you like to build reports and do white papers and basically try to produce some value out of data, maybe analytics is where it's at. So when it comes to data science is really the all-encompassing sort of viewpoint of data in the world of IT. Under data science, we have data analytics. And then we have machine learning and AI, which is really a set of data science. And I'll explain how all this sort of breaks down. So I hope this is going to be a great learning experience for everyone. So I'm going to talk about what these skills really are. The reality is program is going to be number one pretty much for everyone. It's just the level of programming. Mathematics, we're going to want to talk about other skills, so we'll get into that. But basically, I'm going to talk about the demand. The demand for data science professionals has been extraordinarily high. And I'll go through what the career path is as well. And I'll talk about basically job titles, salaries, because one thing too about data science or data analytics, like, you know, being a data scientist is a little bit on the sort of what I would call broad side. You really want to understand it's more, it really needs to be more specialized, and every company looks at it differently. I'll also talk about the career path for data analytics as well. We'll get into AI and machine learning and understand how that plays in as well. And then we'll talk about some of the learning tracks that are available with some of the programs that Quick Start and Texas A&M have, and other resources as well. So we'll get into all those. So let's go ahead and talk about some facts that I think are really interesting. The first is every day about 2.5 quintillion bytes of data are generated. And it is more accelerated with the growth of Internet of Things data, or IoT data. Now, when it comes to, okay, a couple questions. Yes. Yeah, so I'll leave it up to Quick Start to answer that. I believe so. The presentation should be available. I don't know how, but I'll leave it up to the moderator. And is this the webinar for boot camps? Yes, that would be correct. We'll talk about that as well, at least part of it anyways. Okay, so I hope that answered your question. And we'll be talking more about these sections here in a second. Now, TensorFlow has a research cloud, and this program enables researchers to apply for access to a free cluster, basically, of 1,000 TPUs. So a TPU is a TensorFlow processing unit. And I'll show you how that works here in a few minutes. As far as actionable insights, this is where you, as like a data analyst, when you get done with your boot camp and you get done with your training, you start looking for work. This is probably the first step for a lot of you, to go out to a role where you can look at data and provide insight to your company. The goal is to provide value, and I'll talk about how we could do that. Data scientists, they really go and do a lot of different things, but mainly it's about understanding, stabilizing the data, and understanding the relationships between the data and bottlenecks. One of the challenges when you have all of this data coming from all of these different sources is trying to understand, how do we sort it out? How do we put it in a data lake and actually make it work? And when it's in the data lake, we have to understand too that there's different types of data. There's basically data that is structured, and there's data that's not structured. When it comes to hurdles, we have AI and MO. Now, one of the challenges with AI and machine learning is that the expectations, honestly, I think have been bigger than reality. However, it's still an area that has significant demand. So this is an area, if you really like training models, you like quantitative analysis, you like to program, this could be your area to a nice career. Now, as far as options, we'll talk more about the boot camps at the end. But basically, if you're not familiar with Quick Start, basically Quick Start is a global IT training company. They have a lot of different boot camps. And one area that we focus on is, of course, data science and data analysis. Now, there's, of course, different boot camp options. I'll cover that here at the end. But they partner with a lot of different universities. So not only does Quick Start work with the corporate world, they also work with the educational world as well. Let's talk about our first subject, and that is data science versus data analysis versus machine learning versus automated intelligence. So it's really important to understand where this sort of plays in, because generally data science is at the top. In other words, everything falls under data science. And then when it comes to data analysis, we're really going to be using AI and machine learning as part of this. And we want to be aware too, when we're looking at data, it's really about understanding how it's concentrated. How do we generate, how do we generate insight from that data? How can we provide basically actionable results for our company, for our customer? Data science is more of a concept that is used to tackle big data, and those areas include data cleansing, preparation, analysis, of which is used to use predictive tools to provide value. Now, data analysis is a subset of, and I'm saying this for a few reasons, a few times, because I want to make sure we get this. So think of data analysis sort of similar to, for example, if you work in cloud computing, well, just because you work in cloud computing doesn't mean that you work with AWS or you work with Google. Maybe you work with another vendor, and that's a totally different specialization. Even though you know sort of some of the commonality areas, you may not know how to deploy a resource in another cloud. Well, we want to think of data analysis similarly to that. It's a subset. And the reason I'm bringing that up is because I think data analysis is really the gateway for a lot of people to get into data science. Now, AI is really a subset of machine learning. So we want to understand models. We want to understand, for example, how to train our predictive tools that we may be using. And it all just comes down to understanding what the right facets are to consider. So we'll talk more about that. So data analysis, AI, and machine learning are all subsets or specializations of data science. So I hope that is made pretty clear. All right, so let's see the comments and questions. And I'll check it fairly routinely. Okay, let's see. Questions. Okay, so you're a physician with limited computer knowledge, but I'm interested in electronic health records. Okay, well, that's a really good question. If you're a doctor already, you probably have good math skills and you probably have good reading skills. And I'm assuming that you're able to look at data and, visualize it as well. So you really should have a good start. Now, the question is limited computer knowledge. So this is, again, probably more of a, I wouldn't call it a big jump for you, but there's going to be some things to learn, no question about it. And really, it's not so much the computer, the IT stuff that's really difficult. It's really understanding how to use the tools to really produce value. And when I go through some of the tools, maybe it'll help you figure out basically where you can go with it. It's hard for me to really answer this question just, concretely, just because everyone has different experiences, will take a different road in life. But clearly you have the skills to do very well, but which direction you could go is sort of something. Maybe a consultation would be better with someone in the training area, I think. But I have full faith you will do excellent if that is your skill set already. Okay. All right, so I hope this again is really helpful so far. So let's go ahead and talk about some more details. All right, machine learning is really defined as the practice of using algorithms. Now, what is an algorithm? Basically, an algorithm is something that we're going to want to use that is sort of multifold. So let me go and I'm going to show you actually let me hold off on that. But basically think of an algorithm as more of a data structure. And I'll talk about, it's easier to show you in the Google demo than to sort of talk about it verbally. But basically, algorithms basically are a data structure. And as part of that, what we want to think about is it's really a set of steps to complete a task. But data structure is really different in the sense that we're going to store data and then we can manipulate that data. So the algorithm is really more or less used, as a way to accomplish a task. And a data structure is for storing the data essentially in whatever structure. It could be a structured or unstructured, like rows and tables or likes or whatever the data service you may be using. Okay, so machine learning is really what? It's a practice of algorithms to extract data. We want to learn from it. And the main thing is nowadays, and here is really where, for example, a lot of the financial companies hire a lot of AI and machine learning folks because for them, trying to get a model that works to make them money, they pay a lot of money to do that. So a lot of these roles are going to be based in the big cities as well, generally. But basically, if you could go in and look at data and look at how you could manipulate the data, and when I say manipulate, I'm sort of saying, look at it and change it so that you could derive value from it in whatever manner is appropriate, and then put together what's called a forecast. That's like a model, basically, like, for example, with this COVID-19 thingamajig, as I call it. They have this, they always say the model, right? Basically, they're saying that they use basically machine learning and AI to sort of figure out how many deaths would occur on a daily basis and where. That's sort of what they did. And I'm going to actually reference that data here shortly as part of a demo. So I think that's sort of cool. Now, when it comes to data science, we want to talk about, again, it's a broader term. It's not just algorithms and statistics, but it's the whole processing method from start to finish. When the user logs in and makes a purchase, that data science process has already started. On the other hand, the machine learning process, for example, doesn't really start until the questions are asked against it to figure out what time of day is better, or what do you think will happen if we shut down the economy, how many people would be unemployed? That's where they're getting all these numbers from. They're using these models and algorithms, so just be aware of that. All right, so what exactly is a data engineer? Now, there's, of course, different subsets and specialties as part of this. So, for example, a data engineer could also be a machine learning engineer as well, an AI engineer. The terminology is a little bit still overlapping, but also the roles. Also, too, architect is another So just don't think, for example, that it's only one role only. I've seen probably 30 different roles around data science, and about half of them are the same thing. It just depends on the company and what they want to call it. So a machine learning engineer, for example, will be basically someone that is going to build, implement, and maintain learning systems basically in a technology product. That could be like TensorFlow, for example. They focus on system reliability, performance, and scalability. So for example, this is a career path. Now, why would someone go down this way, right? Well, it could be that you're a really good programmer and you like to learn algorithms. You like to understand how things actually sort of start and how they could finish. Not just how they would start and finish, but could finish if this happened or if this happened. So what are the top skills? Well, generally the top skills are going to be cloud, Python, big data, TensorFlow, and learning models. And I would throw in some others as well, like statistical modeling. I would also throw in there data visualization. Again, those are the main ones that typically come up in job descriptions over and over. And when it comes to a data engineer, again, sort of redundant, but a data engineer is another term, but it's a little bit different. So for example, instead of like a machine learning engineer or an ML engineer or an ML architect, we have what's called just a plain data engineer. And this is really sort of more, it's a little bit more broad. So for example, a data engineer will build basically the architecture from start to finish. For example, if you're building a mobile app, that's going to entail basically everything from the user interface on how the user interacts to how that data is processed and collected and archived. Hello? Okay, I thought I heard something there. Okay, so just be aware, again, there's a data lifecycle. So the data engineer is a little bit more broader term, and it includes basically software engineering skills as part of this. So like if you're in machine learning or AI, that's more a niche area, whereas a data engineer is somewhat more broad. Now, there's going to be some overlap. So whether you become a data science expert or data engineer or machine learning engineer, there's some commonalities you have to learn. Now, Python and R, these are going to come up over and over and over. However, with data engineer, it's also more about other services as well, databases, data warehouses. So those are the top skills. A data analyst. So what is a data analyst? A data analyst is going to be someone, now this isn't as technical as like machine learning or a data engineer. This is typically what I would typically call, now an analyst is what? Typically in the world of business, a business analyst is a broad term, right? And it could be someone just collecting data and then putting out a statement about that data. That's what a data analyst really is. So you do a lot of work around Excel, Tableau, however you say that, I never said that right. And you see Python again and again, right? So if you don't get the point now, you need to be a good programmer to really do well in this area of data science. So if you go to LinkedIn now or Glassdoor or whatever you may use, you're going to see Python over and over and over. R is actually an up and coming area as well. Now, Excel is actually still used a bit. I was still a little surprised to see that, but believe it or not, I probably came up with about 300 jobs that still require Excel. A lot of companies still use Excel, whether they're a Fortune 500 company or not. So we want to be aware of that. When it comes to a data scientist, now this is a little different. A data scientist is going to be more sophisticated from an analysis perspective. And what does this mean? they're going to probably need to know a lot more than a data analyst in the sense of technical merits. Typically, the average data scientist needs to have a PhD in the Fortune 100 or 500 companies. So just be aware, this is if you want to become a true data scientist, you're going to be going to school a long, long time. Now, if you go on LinkedIn, I saw most of the companies like Facebook, LinkedIn, even Microsoft, also the financial companies like I think Chase and a couple others, they require at least a master's degree. So this is not a job you jump right into. This is a job that you need to be in the business for 10 years or so generally. Okay, now they use a lot of math. In other words, this is statistics. This is computer science. You need a technical degree to even get started in the field. And this is true throughout. So the R and Python again, right? Now regression testing is something that will come up. Data structures, algorithms, right? This is what this data science really requires. It's a pretty complex area. So I like to compare again the data scientist sort of to like the MacGyver, if you ever seen that show many years ago, where he could fix and do anything. That's the data scientist. Whereas like a business analyst or someone like that is a little bit more niche and not as, you know, widely, I guess, widely experienced or whatever in other areas. Okay, now who should opt in for a data science career? Basically, this is a career that has different roles and responsibilities. There's no really two same roles that have the same responsibilities. When we get into data science, it's really programming. It's everything from SQL to NoSQL. It's data points, metrics. Again, these are just some of the things that you need. It's really a career that you need to be constantly learning. When it comes to proficiency, generally data science careers want you to be able to take a technical problem or take data and translate it into business decisions. Or I like to call actionable insight is another way to look at it. In other words, you're working for a large company. Let's say you work for a hedge fund like Bridgewater. Now, I know Bridgewater to agree because I used to do consulting with them. About 4 or 5 years ago, they had over 80 data scientists. Okay, so that's a lot. I don't know any other company that comes close to that. Now, what I will say is, again, they get paid really well, but they have a lot of pressure. There's no question. So with that said, just be aware what this comes down to is you need to figure out ways of how to collect data, ingest data, and then solve a problem. Now, typically a data analyst has data and then they try to visualize it and figure out what to do with it after. A data scientist is more proactive and also much more detailed. So a data scientist needs to also tell a story. Lastly, you need to be extremely flexible. Machine learning, statistical modeling, and even UX experiences. And UX is user experience, basically. All right, now what about data analytics? So we know what data science is, right? That's like the guru of all the gurus. Data analysis is what? It's a subset. You're going to be more specialized. In other words, you don't have to know every cloud platform out there. You just need to know AWS or Google. That's my sort of comparison. So with data science, you're going to be really good, for example, at maybe, for example, statistical analysis. Or you're going to be really good, for example, where you might work for, let's say, the Mortgage Bankers Association, where their data analysts always look at mortgage data and they collect data from different sources and they put together basically reports that they publish or sell. That's your data analyst. However, you still need to have math experience, data wrangling. We have to extract value. We don't have to figure out how to get the data. In other words, we probably have the sources. We just have to figure out how to get data, and we need to visualize that data. What about the skills for data science and data analytics? Again, these are just some of the common skills that are commonly needed. And you see some of these come up, Python, R, over and over. So let's talk about a nice example you can go look at. Now, when it comes to data experts, if you go to Stack Overflow, this is a developer community. Python is currently listed usually number 1 or 2 as the most wanted skill sets. So if you're a Python developer, you probably won't be unemployed, or you shouldn't be anyways. There's a lot of demand. And JavaScript, Go, so on and so on. So I would encourage you to go to Stack Overflow and look at, again, the most wanted or most loved, and the title of the article is here. And they update this graph pretty routinely. So there's no question the demand for data science requirements is there. Now Python, again, as I had stated, Python from a different survey, same thing, the fastest growing language. According to Indeed, another source, it's the most demanding programming language in the USA market, with over 74,000 jobs available in January. So that's part of that requirement. So if you get into data science, you have to learn Python. It's just a fact. So just be aware this is something you have to learn. Okay, the average salary is about $120,000 if you're a good Python programmer. Okay, let's see. We have a few more slides. I'm going to break for a little demo here and walk you through some data sets and give you an idea of what you might be doing full time if that's what you want to do. Okay, when it comes to data science and the demand for professionals, there's a lot of great content out there. There are so many. I just quoted pretty much just a few. So the demand for data science is clearly growing, and it's all about data-driven insight. And what does this mean? Well, companies, they need to be able to look at data and understand it. Companies are really great at collecting data, and they collect everything. They save everything, but they're still not really good at getting value out of the data. And this is where you come in. You come into the company and you get started and you start sifting through different data sources and say, oh, well, you know what? Maybe I could find a pattern that might solve a problem for the company. Or the company hires you and says, here's a problem we're having. Can you look at the data sources and give us a solution or provide data, visualize that data? That's what this is all about. Now, Indeed showed a 29% increase in demand for data scientists year over year. Since 2013, there's been over 344% growth in that area. So a lot there, no question about it. When it comes to demand, it is even higher for professionals that have value experience. In other words, you've already been solving problems. Okay, can someone please put their thumbs on mute, please? Let's see here. Getting a lot of echo. Let me see. Oh, okay. All right. Yeah, I'm getting an echo. I'm not sure who it is, but okay. I think that solved the problem. All right. Now, as far as wages and what can we expect? Now, I'm going to be honest. The salaries for starting data experts isn't exactly, great. I mean, compared to some other parts of IT. However, it's still good. So, for example, according to Glassdoor, it's about 95,000. Now, generally, the starting salaries are actually in the low 60s from what I'm seeing. But again, you're just getting out of school, you're learning, that's not a bad start, right? Now, there's a lot of different titles. I'm going to be honest. When it comes to data science, data engineers, qualitative analysis, or qualitative analyst, or data analyst, those are some of the terms that we see typically that are still in the data science area. But maybe when you look at qualitative analyst, you're like, well, what does that mean? Well, that's a data scientist. You need to look at the numbers and how to take the numbers and actually correlate them to solve a problem. For example, in the world of mortgages, we have what's called mortgage-backed securities. Well, in the good old days of math, it used to be that 10 times 10 was 100. But in today's world of the financial sector, 10 times 10 is not 100. It's pretty much whatever they want to create. That's the world we live in. And when it comes to qualitative analysis, if you're working at a bank, you have to figure out if this happens and I take this variable and that variable, I have to qualitatively or quantitatively put together an assessment of what this could sell for. This is what happens, for example, in New York and London. And I spent a lot of time at Bloomberg years ago, so I know more about this than I probably would want to know. Now, when it comes to IBM, right? Now, we know IBM, one of the largest tech companies out there. They're predicting by 2020, and again, we're already in 2020, so this is an older statement, that there'll be over 364,000 openings available in data science. Now, I don't know how they came up with that number. The report didn't say it, but I'm throwing it out there because that's the number they came up with. I'm assuming that's worldwide. Also, too, 84% of enterprises have launched a data-based initiative. In other words, they want to make decisions better by using data. What a great concept, right? So companies still do a lot of their decisions off the hip, right? It's not about looking at data, it's about feelings, it's about politics generally. So you as a data professional will go into companies and put together this data initiative to help the company do what? To make better decisions and be more accurate. And that's according to LinkedIn on a study that they did. Also, another thing that was picked up from LinkedIn was that over 4,000 new data science jobs were created last year in the US alone. So what is the career path for data science? Very good question. As we know, it's a wide net. And the career path is just as wide. It just depends on what you want to get into. But there's some commonality. We need to have extensive training and degree requirements. That's just a fact. I don't see, a matter of fact, I looked through probably 30 different job roles yesterday to just double check, see if there's anything interesting. Every one required at least a bachelor's, if not most required a master's or better. And the degrees need to be technical. They need to be in mathematics. They need to be in computer science. They can't be in liberal arts or anything. So you have to go with something technical if you're going to be competitive. Okay, what are the titles? Another title that I see quite a bit of is research data scientist or business data scientist. So what's the career path? And I sort of said, right, already, it has to be technical. There isn't going to be a lot of job descriptions that will say you don't need a degree or at least a master's. And that degree needs to be math, science, or computer science. Also, or statistics or something, something close to that. Okay, they almost always require Python, and R is like a bonus. Statistics, probability, mathematical analysis, linear algebra, calculus, discrete math, so on and so on, right? Lot there to learn, no question about it. The career path is going to be tied quite a bit, believe this or not, to publish papers. So when you get into your first role, your first order of business on the weekends is to start putting together papers that you publish. That is something that is really a best practice from what I've seen from experience. And I can tell you also, getting that master's or doctorate degree is really important once you hit 5 years. You could get started with the bachelor's. It's just, you're not going to get into larger roles that pay a lot more until you get that advanced degree generally. And then data analytics is sort of similar. It's just, again, sometimes instead of a scientist, they call it an analyst. Analyst is more specialized. All right, now what about AI and ML? When it comes to AI and ML, it comes down to understanding areas. If you're going to become a data scientist, for example, understanding what AI and ML can do and how you would use it. And it comes down to predictive analytics. So for example, a data analyst typically is going to basically look at data and just sort of give an output based on it. A data scientist is more proactive. They're going to ask, well, what can this data do for me or do for the company if I change it? And how can I change the data or collect different types of data so that I get the outcome that we require? And that's what it's about. So ML is a subset of AI. Also, too, machine learning handles data without human involvement. So it uses regression, clustering, predictive analysis, or analytics, I should say. So what about the titles and salary ranges? So before I cover that, why don't I go to a demo and talk about, let's see, let me stop my share here, and just give you a look and feel of what you can do in data science. Okay, so let me share my screen here, my other screen. Okay, where is this browser? It is. Okay, so let me bring up, okay, now that I found it, and you should see this here very shortly. So I'm logged into Google Cloud Platform. Google Cloud has basically several data analytics, data warehousing, machine learning, and AI tools. They're excellent to use, very simple to get started. So the service is called BigQuery. So BigQuery is going to be a service you want to use when you want to look at data and ask questions against that data. And can we see the screen okay? Let me just make sure. Okay, question, is Google Cloud free? So excellent question. There is actually a free tier and free credits you could use. And again, it's up to you to determine, if you want a paid account or not and how you go about it, but it is free to get started. And if you go over here, I'll show you where you go to find out. Okay, free tier. So they have sort of similar to AWS as well. They have a free tier. And if you go over here, they have free credits. So if you're new to Google Cloud, and forgive my pronunciation, I think it's Satyaki, hopefully, or Ray, maybe, forgive my pronunciation. If you go type in free tier Google, you can sign up for the free credit. If you are new, you'll see sign up instead of go to console. Because I've already signed up and I'm already a paying member, basically it says go to console. But there's always free products. So if you go down here, this is the always free. So you have a certain amount of services that you could use for free. So I hope that answered your question. Yes, the answer is there's services you could use that are free. You could also practice on AI and machine learning tools as well. So you get up to 5,000 units per month. So a unit is really a combination of an amount of data and the requests that you make. And then also you have translate. These are other AI services as well. Again, a lot of machine learning and AI tools are free. So I hope that answered your question. All right, now, because we're in the world of COVID-19, so I'm going to talk about Google Cloud. So if you log into Google Cloud, what we could do is go to BigQuery. So BigQuery is a data warehouse. And so the first thing we want to look at is go over to BigQuery here and actually look for what's called the public data sets. So the public data sets are free data sets that Google has imported into BigQuery. And that way you go and play with these and actually start running queries. And then I'll show you how we could visualize data as well. So because we're talking about COVID-19, they actually just uploaded last week information on COVID-19. So let's say if I go to Italy, I could search by national trends, by data by regions, so on and so on. Or I could select, again, the whole country as well. So this will tell me information about like province. Let's go to national trends. And what I could do is, let's say I want to find out the number of deaths, okay, or recovered. Let's be positive and look at recovered here. And before I do that, I probably need to actually start it. So what I want to do is go to compose new query and then query table. And then I'm going to go and put in recovered. So what I'm doing is I'm going to select recovered from the public data set of COVID-19 Italy, and I'm going to limit it to 1,000 outputs. I'm going to go run. And you can see there that it simply puts out basically tables and rows, very small data set. I just initially selected that. And I could add additional data sets as well. So I can make this as complex or simple as possible. Then what I could do is go here to explore data. And I could use a product called Data Studio. This is going to bring me over to the Explorer. I now need to select a chart. And I could select any chart and what's it do. It brings up this beautiful capability where it just takes the data and does this for you. So, and then what I could do, I could change the style. I could slice it differently. I could order it differently. I could go down here and change it from labels to percentages to values that I want to set, whatever I want to do. And if a bar chart is supported for the, depends on, again, you need all the metrics there. And I could go ahead in and plot it out any different way that is supported. So when I add additional types of data, it'll go ahead and adjust the chart based on what is available, you know, the number of rows and columns and comparisons that you have. So a lot there, right? So this is just a start. Now this is just one of the many tools that are available. So this is called BigQuery. So actually this is BigQuery and then this is Data Studio. Then what I could do is, let's say I go back here because that looks prettier and let's select that. And then what I could do is change that. And then I could change this to, let's say, COVID results. and then I could add another chart to compare against as well. And I could just save this. I could import it, export it, whatever I want to do. So I go over here to save. And again, I could connect up to any number of services that I want. So I go over here, I have to accept the terms. And then yes to all, of course, because I love that. And now it'll save this locally in Data Studio. And that way I could always go back. I could also export it as well. So I could do many different things with this. Then also, if I go here, this is actually tied into analytics. So what's nice is I could use Google Analytics and also ingest that data. And again, this is just one of the many things we could do. All right. So that's BigQuery. Now let's go over here and talk about another service called TensorFlow. And then we'll need to get started on the closeout. Okay, so now TensorFlow is going to be a tool that we probably will want to use when we get into, oh, I'm not where I should be here, hold on. So TPUs. So I want to point out TPUs actually. So you can see there I have actually a cluster I deployed with TPUs on it. And you can also deploy this in Compute Engine. So if I go over here to Compute Engine, and I go over here to select TPUs, I could enable the API. There is a cost though. Again, you're going to play with this, but be aware that TPU is basically a TensorFlow processing unit. It's meant for you to run your models in against. So this is how you could train your machine learning models. So you can go ahead and enable that. Now, another tool that you could use is go over here to tensorflow.org. And this is where you go to actually use another cloud service called tensorflow.cloud. If I go here, there's tutorials you could use. There's a guide. But if you scroll down here, you can see that they have, for example, some example code you could start with. And this is a good way to start training your models to play around and see what happens if I change, for example, the model from Keras to another version, for example. Or if I say compile different data, I'll get a different output. Now, if I go to run code, they have an interactive notebook. So I go run code. Now, to do justice to this is about 40-minute exercise. So we don't have time to go through everything, but I want to get folks started if this is of interest. And again, this is a whole separate sort of discussion generally, but I want you to be aware of this just to give you some ideas. So what this is going to do, this is sort of like a tutorial with sort of like what would be called a training model combined all at the same time. And what we could do is scroll down, and if you scroll here to each of these brackets, so for example, you're going to, so what the way this works is this is called, actually, they changed the name of this a little while ago. It's called Google Collaboratory. It was like TensorFlow Cloud, but it's actually now called Collaboratory. And this is going to run Python. So remember, Python comes over and over, right, for a reason. So what we could do here is we could select this arrow, and what this is going to do is execute that in this session we're in. So that'll go ahead and execute. And then I go down here, execute this data set. And then when I highlight this, you'll see that it was executed at 5:52. Then I scroll down here, you can see that it's going to run. And then down here, this just ran. So this, what this did is it ran a prediction model, and it looked at an array of data. And here is sort of where it's at. And now we're going to kick off, again, another function that is going to try to interpret this differently. And then we scroll down, and for time purposes, I don't have time to go through everything, but I'd highly encourage you to go through. And yes, you could use GitHub as well. So so there's plenty of great resources on GitHub. So also too, this is an IDE basically, a developer environment. So you go over here and you look at the code history. You could look at differential notebooks. You could insert different cells. You could look at the runtime. I could restart this as well. And there's tools that we could look at. And then over here, these are the resources we could look at to look at the local runtime and then edit. So this is just one of the things we could do. Then if I go back here, if we scroll down, there's an expert one as well that you could play with. And then go down here, I think over here, there's TensorFlow. Here's a GitHub. Here's the GitHub for TensorFlow. Over here is the repositories. You can see here, now look at this, top languages. What's up at number 1? Python. So one of the things I'd recommend is that you would go and maybe download a tool and to see if you really want to get into this. It's called Python or PyCharm, I should say. And this is basically a Python CLI. And then I also used to have over here a interface, an IDE called PyCharm. And I think I took it, no, I took it out probably, but I'll show you where you can get it though. I was a little tight on space, unfortunately. Let's see here. Thought I had it. Silly me. Okay. I have R3 demo bench, but I don't have Python. Okay. Must have uninstalled it. JetBrains. Oh, here it is. I was looking for PyCharm. I knew it was something wasn't right. I know I didn't uninstall it. Okay. So PyCharm is basically a local IDE you could use to compile your Python code. So you can see there, anytime we see a .py, that's Python. That's basically saying you're working with Python. And again, you can see here I have a blockchain that I was deploying here in Python. So Python is just the all-around Swiss knife, basically, of programming. It's really easy to use. And also why people like it so much is because there's such a robust amount of tool sets available. And if you go to GitHub for Python, it's one of the most active out there as well. So feel free to check that out as well. All right, I hope those demos gave you some different insight than just PowerPoint anyways. I do need to go back and go back to the presentation here and finish up the, so let's talk about salaries. And I think that's showing, should be, let me check the chat before I forget. Okay. Okay, question I might have missed. Ralph is asking, I don't have a technical degree. Does that matter? Can one do the course and still be employed? I don't know if that's a question for me to answer, but I don't, again, I think a lot of success in life is really, revolves around your attitude and how many times you're willing to hear no. And again, perseverance is sometimes better than having a degree. So I'm not one, that gets into math. I don't have a master's or a PhD. I'm not into that. And, I'm widely known pretty much all over the internet. So I'm okay with that. Could I get a master's? Could I get a doctorate? Sure. But I just don't feel it matters at this point in my life anyway. So again, it's all about attitude. If you're in your 20s, you want to do that, again, whatever you want, it's your call. So with the boot camp, it's meant to provide, insight around what you need to know around data science. Now, the boot camp gives you more information than what most of these degrees would provide you anyways. So, but I'm not really qualified to get too deep into that. I'm just giving you an opinion. I'll leave it up to the moderators to answer that or direct you to someone that could give you a better answer. Okay. All right, I think I answered all the questions that I see. So great. Is there anything else I missed? Well, if you have a master's, I don't, I have to say I'm pretty ignorant. I would think petroleum engineering is probably a technical degree. I'm guessing it's probably not a liberal arts degree. So if you're technical, you're probably going to be just fine. But again, I'm going to leave that up to the advisors to sort of follow on that, I think. Okay, I hope that gave you a little bit of insight. Yeah, engineering. Okay, there you go. So again, I figured it was technical, but again, I don't want to make judgments on something. But again, if you have it in basket weaving, that's probably not a technical degree, right? So again, that's a discussion outside of what I like to talk about as far as qualifications for degrees. So I'm just telling you like it is in the real world, and I'll leave it up to you to find better advice in that area. All right, so let's talk about the salaries and the titles. Now, we already know that titles and salaries are going to be wide-ranging. So here were some of the salary ranges that I have basically looked for a couple days ago on Glassdoor. Google, Coursera, for example, had different reports, LinkedIn as well. Now, a data analyst is about 71,000, and if you go to LinkedIn, when you go to a job, it gives you that insight of what the salary is. But also LinkedIn and also Glassdoor does a really good job with their reports. So again, this is just a sort of average salary area. Now, if you're in New York or San Jose, those salaries are going to be higher. But again, the cost of living is higher, of course, in a lot of places as compared to a lot of places. So this is just sort of the average that I, was reported. So that's what I'm looking at. Okay, so a machine learning engineer is about 131,000. A data engineer is 115,000. A data scientist is about 120. A data analyst is about 71,000. Now, when it comes to basically obtaining, deeper training, proper training for what you want to learn, definitely understand that Quick Start has a lot of options, and of course, bootcamp options as well. I'll leave it up to the moderators to tell you more about that. So let's put this all together. When it comes to demand for data science, there's no question that it's a really in-demand area. We know already that some of the common requirements, Python. Python is number one. We have to learn Python pretty much in almost all roles around data science. Now, AWS and GCP are in demand. So if you want to get into cloud and data science, those are really good ways to learn more. So you can see, for example, just in Google Cloud, I went through 2 services, but there's probably 30 different services around data-based services that you could get into and actually do your work as a data scientist, a data analyst. And again, salary ranges were wide range, right? And then data science does require solid learning and high degrees. And again, the Fortune 100 companies are pretty strict. I couldn't find, like if you look at Accenture or Deloitte, they're all requiring master degrees at least. And they want published papers. So again, you may start out at a smaller company and then work your way up, of course. Okay, now as far as bootcamp learning tracks, there's of course a different programs as a data science and a data analytics program. Now, I'm going to talk a little bit about this, and I'm going to turn it over to the moderator to fill in some of the blanks for that matter. Now, there's, of course, any bootcamp program, there's things we have to look for. And this actually provides some really good value, because not only do I teach boot camps for different companies and have in the past, I have courses on different areas, and I can tell you right now, there's 3 things we need. The first thing is can this get you job ready? And it will. And I'll go through how that does here shortly. Also, it's going to enable you to build a professional portfolio. So what does that mean? Well, to build that portfolio, going to a boot camp, you have to do projects that you publish on GitHub, for example. And you need to really build that portfolio. Career counseling is important, but also, again, those are probably the three most important. I would also say this is a really value added as well, right? So if you get a certificate of completion from a university, then that gets attention, right? So that's a great deal. And then, of course, payment options that, again, I'll leave it up to the Quick Start folks to talk about. Now, here's the curriculum for data science. As you see, it's a good amount of weeks, and there's a lot of different areas that you'll cover. Everything from Python, of course, to visualing data, to storytelling, to using cloud services with Azure, for example, and R. Again, R is, number 2, and will likely be number 1 sometime. It's just Python has just been around longer and just has a bigger following. But R does some things, especially around statistical analysis and analytics, that Python just doesn't do as good. So again, a lot of potential here. So that's data science. And then the data analytics, you could see here, is again, just as detailed. I won't read everything to you, of course, but you could see that some of the themes are covered again, right? Python, data visualization. Also, too, they cover Excel, which actually is important, especially for your first job. Chances are, and there's plenty of good blog posts of folks that do data science or have started their first job. One of the first things you're going to learn is going to be Excel. How to use Excel to actually determine, for example, specific report requirements, visualization models, dashboards, etc. Python, right? Again, we keep on seeing that. So I hope that is clear